In this video, we're going to look at another example of volumes by slicing. A wedge is cut out of a log with the shape of a circular cylinder of radius r. The wedge is removed from the log by a vertical cut perpendicular to the axis of the cylinder and another cut at an angle of 45 degrees along the diameter of the log. Find the volume of the wedge removed. As usual, we start by drawing a picture of the solid and the area slice. So you can see the wedge that's been removed. Our goal is to find the volume of the wedge that's removed. Let's start by placing the x-axis along the diameter where the vertical cut and the 45-degree cut meet. So here's the x-axis. Now let's draw in this cross-sectional slice. So here it is. There's a cross-sectional slice. And let's label these. The lower coordinate is A, upper coordinate is B, and we go across, and this is C. Here's 90 degrees, and this angle is pi over 4. And there is one of the cross-sectional slices. There's infinite number of these. We add up all these cross-sectional slices in the x direction to find the volume of the wedge. All right, so we can see that the area slice perpendicular to the x-axis is a distance x from the origin, this distance x. And let's find the distance AB. The distance AB is simply y, because y represents the distance to the x-axis. But we want y in terms of x. So looking at the equation of a circle, we have x squared plus y squared is equal to r squared. So y is going to be square root of r squared minus x squared. Now let's look at the height of this wedge. So the length BC. To find this length, we simply apply trigonometry. Tangent of pi over 4 is equal to opposite, which is BC, divided by adjacent, which is AB, the length AB. But the length AB is defined as y. So let's solve for the length of BC. The length of BC is simply y times tangent of pi over 4. Tangent of pi over 4, tangent of 45 degrees is simply 1. So the length of BC is y. And y is equal to root of r squared minus x squared. So this is y equal to root of r squared minus x squared. And the area of a triangle is simply 1/2 the base. And the base is AB. 1/2 the base times the height, which is BC. And this length is y. This length is y. That's 1/2 of y squared. And we also have y in terms of x. So now we can get the cross-sectional slice as a function of x. That's the next step. So we want to find a formula for a of x. We know that the area of a triangle is 1/2 the base times the height. So that's 1/2 of the base, which is the length AB, times the height, which is BC. That's 1/2 y times y. So the cross-sectional slice as a function of x is going to be 1/2 y squared. But we defined y in terms of x. From here, you can see we have the relationship between x and y because of the equation of a circle, x squared plus y squared is equal to r squared. So we get 1/2 times y squared. If you solve for y squared, we get y squared is equal to r squared minus x squared, isolating for y squared. So notice that we place the x-axis along the diameter. Then the base of the wedge is a semicircle with the equation y is equal to root of r squared minus x squared. And the x values range from r to minus r. If you go back to the diagram, here is minus r and r. This is the x-axis here, right here. And now it's just a matter of integrating and finding the volume. So what we have is we want to integrate the area slice a of x to find a volume. Volume is equal to integral from a to b, a of x dx. The lower limit of integration, a is equal to minus r. The lower x limit of integration, the upper x limit is b is equal to r. The cross-sectional slice, a of x, is equal to 1/2 times r squared minus x squared. So the volume is equal to integral from minus r to r, 1/2 times r squared minus x squared, integrated with respect to x. Now we can apply symmetry because the integrand is an even function, is symmetric about the y-axis, so we can simply take 2 times the integral from 0 to r and save ourselves some computation. 1/2 times r squared minus x squared dx. And so volume is equal to 2 times, 1/2 is a constant, passes through the integral, 2 times 1/2, integral from 0 to r squared minus x squared dx. And 2 and 1/2 cancel out, we get volume is equal to, what is the antiderivative of r squared? We get r squared x. And what is the antiderivative of x squared? Reversing the power rule, we get x cubed, divided by 3, evaluated from 0 to r. Now apply the fundamental theorem of calculus, putting the upper limit in, we get r cubed, minus putting the upper limit into x, we get r cubed over 3, minus putting the lower limit, we get 0 minus 0. So we get 1 minus 1/3, that's 2/3. 2/3 r cubed is the volume of the wedge removed from the log. This is the volume right here that we've removed. So we have found the volume of the wedge by applying the method of slicing. All right, thanks.